Hi everyone, this is the counting sort problem by HackerRank. The link to this problem will be in the description. So the first thing it does is it talks about quicksort and how it has a runtime of n times log of n, which is a lot of the sorting methods will have this type of runtime. Counting sort, its runtime we'll discuss at the end. I'm a little surprised it doesn't tell you here, but it is better than n log of n. The only thing is there's not that many use cases for it, but it does come in handy uh, when it can be used. And so then it gives us an example of how counting sort works. I'm going to skip over this just because we're going to do a walkthrough together in our slides, which is going to be a little bit more clear of an understanding than the example they give here. So lastly, our constraints for this problem. So we're given an array, and the size of the array will be anywhere from, it can be greater than or equal to 100, but less than or equal to 10 to the power of 6. And the numbers in our array can be greater than or equal to 0, but less than 100. So this is an important factor right here for counting sort, right? Because in order to use counting sort, you have to have a small set of values such as we have here. So knowing that all of the elements can only be 0 to 100 means we're able to use counting sort, because the larger your values can be, then the more values you have to store in memory, and that's the downside of counting sort. But since it's a small set of numbers, it works for this problem. So overview of the solution. The first thing we do is instantiate an array count of numbers with 100 zeros. Then our second step is we iterate through the given array, and for each number n in the given array, we increment count of numbers at index n. So let's walk through the problem. Let's suppose this is our array that we are given, and let's say there's 1,000 elements. We're only going to look at the first 4 elements of the given array, just for the sake of the walkthrough, right? Because it'd be too much to go through 1,000 elements in a walkthrough. So the first step is instantiate an array count of numbers with 100 zeros. So here's our count of numbers array, and it has 100 zeros. And the index starts at 0, so 0, 1, 2, 3, 4, 5, and then 99, right? Because we start at 0. So if the size is 100, then the first index is the first index is 0, and the last index is 99. Our second step is to iterate through the given array. For each number n in the given array, increment count of numbers at index n. So the first number in our given array is 0. So we're going to increment the count at index 0, right? So we incremented that count. Now the second number in our given array is 5. So we look for our index 5 and we increment that count. So that becomes 1. Then the next number in our given array is 3. So we find index 3 and increment that count. And then lastly, we have 5 again. So we find index 5 and increment that count. And that's it. So now we have all of the counts of our given array, right? So if we look at 0, there's 1 0. If we look at 5, there's 2 5s. If we look at 3, there's 1 3. So go ahead and pause and try to solve this on your own, and then we will solve it together. The first thing we want to do when solving this problem is instantiate our count of numbers. And we want to instantiate the counts with 100 zeros. So our array list size is going to be 100. And we're going to add all of those zeros. And the reason why we're starting with 0 is because since we haven't gone through our given array, we don't know what the counts are. So we have to start with a count of 0, then we will loop through our array and increment the counts. So let's start by adding 0. So this for loop is going to loop 100 times, and 100 times it's going to add 0 to our count of numbers. Now that we've done that, we can loop through our given array. So we're going to say our index is 0, and while our index is less than the size of our array, we will add 1 to the index. The first thing we'll do is get the current number in our array at index I. Then we want to get the count of that current number. So we're going to say integer current count equals count of numbers, right? Because our count of numbers, that's what's holding all of the counts of our numbers in this array. So we're going to say count of numbers dot get our current number. So this is going to return our current count. And now that we have our current count, we can add 1 to it. So current counts plus plus. And then we will add that back to our current numbers. So we're going to say we're going to add it back at the current number index. And we're adding back the current counts. Right? Because we've added 1 and then we put it back. But rather than adding 1 here and putting it back, we can just add 1 here. And that allows us to remove this line. Cool. So that will get us all of our counts of the numbers in the given array. So all that's left to do is return the count of numbers. Let's go ahead and copy and paste this into HackerRank. And then submit the code. Great, so everything ran successfully. Now go ahead, pause the video, and take a moment to solve for the time complexity and space complexity of this problem. So for time complexity, we're asking what is the relationship between our input and how long it takes to run this method. So if we go through, we see that this will always run regardless of our input. And then we have a for loop here. But how many times does this run? And is it dependent on our input? So this for loop runs 100 times, but it is not dependent on our input, right? Because regardless of the size of our array, this will always run 100 times. So the runtime of this is O of 1. Then we have another for loop, and this for loop is dependent on our array, and specifically the size of our array. So it'll always run n times, where n equals our array size. So our time complexity, because we always take the bigger one when we're doing big O notation, and O of n is bigger than O of 1. So our time complexity is going to be O of n. Now let's calculate for space complexity. Space complexity, once again, it's asking, is there a relationship between our input and how much space is being used in the method? So we see here that we have an array, a list of integers, and this has a capacity of 100, right? And we're adding 100 numbers to it in this for loop. But is the size of this array dependent on our input? It's not, right? The size of this is always 100 regardless of what our input is. So this is also going to be O of 1, right? The size in terms of space complexity is O of 1. Now inside of this for loop, we could see that we are setting numbers to our count of numbers, right? But this set, it's always at one of the indexes from 0 to 99. We're not changing the size of this array list. The size, Even though we're changing the values in the array list, we're not changing the size of it. So it still remains O of 1. So the space complexity of this problem is O of 1. So that concludes this video. Thank you guys for watching. If you have any questions or feedback, please let me know in the comments.